4 and 4.5 video. The reason why I'm putting this one together is it's all about graphing, and I think of all the function lessons that we did, this is probably one of the easiest parts. So if you can get over that writing function thing, that's the hard part. This one, it should be a little bit easier. So it's asking you to graph the function for a given domain. That part is pretty key because this is the only domain you're allowed to use. Another way of saying that is that domain are the x values. So to be able to graph something, you need coordinate points. What's nice about this is because they told you the domain, they are telling you what the x values that you are allowed to use for your coordinate points are. So if you think about it, we can list our coordinate points here because they are -1, 0, 1, 2, and 3 for the x coordinates. And what we need to know then to be able to graph them is what are the y coordinates. And it's a very, very easy thing to do. If this is x, you can go to this expression right here, this equation, and put this in for x, calculate it, and get an answer for y. So I'll show you how to do it for the first one. It would say y equals absolute value of -1, because we're using -1 for x, minus 1. Well, the absolute value of any negative number just turns it positive. So really this is 1 minus 1, and that's 0. So since we got 0, we bring it back over here, and that is our y coordinate. And so you need to do this for each one of these points. Sometimes it's not too hard. In this case, it's really not. If you think about it, just put 0 in for this. Absolute value of 0 is still 0. Minus 1 is -1. Let's do that for each of the other points. If we put a 1 in for x, absolute value of any positive number just keeps it positive. So absolute value of 1 is still 1, minus 1 is 0. Absolute value of 2 would be 2, minus 1 is 1. And the absolute value of 3 minus 1 is 2. So that means now that we have our 5 points, we can plot them over here. This means left 1 and up 0. This one means left 0 but down 1. This means right 1, up 0. This one means right 2, up 1. And this one means right 3, up 2. So you get kind of a check mark shape there. Okay, the big thing is if you look at this for just a moment, this was the only domain allowed, which means that these are the only x values allowed, which means these are the only points you can graph, and that means that when you graph these points, you shouldn't connect them because that would include all the ones inside it, and you don't want that. You only want the points that you graph. So this is the graph of what's called a discrete function, because it tells you specifically what points you are allowed and no other ones. So that'll be our transition into number 2 then. The difference is very, very subtle. It's that there is no domain given. Which is okay because you can still come up with your own. The only thing you want to do is make sure that you get enough points to actually draw a shape for your graph. So what I usually suggest is start with -3, -2, -1, and 0 for your x values, and then do the same thing for positives, 1, 2, and 3. That way, regardless of what your graph looks like, you'll have a really nice picture because you'll have the negative side, 0, and the positive sides. So once again, if we want to know what y is equal to, much like the problem above, we take -3 and put it in for x. In this case, -3 squared minus 3. -3 squared is 9, positive 9, minus 3, that's 6. And I'm going to do this for each value that I have here. -2 squared is positive 4, minus 3 is 1. -1 squared is positive 1, minus 3 is -2. 0 squared minus 3 is -3. 1 squared is 1 minus 3, which is -2. 2 squared is 4 minus 3, which is 1. Finally, 3 squared is 9 minus 3, which is 6. So I have all these points to graph, so I'll go ahead and graph them all. We get kind of a funny shape to this graph, but that's okay. It happens. Later on, you're going to learn that this graph, anything with an x squared like that, is called a parabola, and the function is called a quadratic function. But for now, it's just about being able to graph a function. And the reason why I drew a line is because since I wasn't given a domain, I can assume that any value for x is okay. So I chose some easy ones to help me graph it, but really this picture should include arrows on the end and should have lines on it, because any value for x, in other words, basically any point along this path, is okay. Unlike this one, where it told us that we could only use certain values, this one did not tell us that, so we're allowed to use any values we want. We picked some easy ones to help us graph it, but really any values are okay. So that's why this one has a line to indicate any values are okay, and this one doesn't, because it was only a certain domain. Alright, and then the last one on this page deals with a word problem, which incorporates something we did before called a reasonable domain and range. But it's going to help us graph, and it'll make it easier because we know what it is we're trying to graph. So this time we're talking about trying to graph y equals 0.5x. And if you read it, it says y is the miles that the fish swims, and x is the hours that it takes. So we still need to graph it, but we don't have any domain, so we're going to have to come up with our own points. But here's the thing, okay? Since you only really need the positive side of this thing, really the reason why that is because if you think about it, how could x be a negative number? Now, if this was just an equation like this, it could be. But because we have a problem that tells us what it's about, x hours, how could you have a negative number of hours? So we know that the least number of hours we could do really is 0. So we wouldn't want to have any negative numbers here, because you can't have a negative number of hours. So we pick something that'll help us out to graph it. We'll do the positive side, but we have no need to do the negative side because there isn't one, because there aren't any negative hours. So we do this the same way. Put a 0 in for x, and our answer would be 0. If you put a 1 in for x, you'd get 0.5. If you put a 2 in there, you get 0.5 times 2, which is 1. And if you put a 3 in for x, you get 0.5 times 3, which is 1.5. So what I do is I plot these 4 points, 0, 0, 1.5 right there, 2, 1, and 3, 1.5. And see, again, because I wasn't told a specific domain, I can actually go ahead and draw a line between these things, because I know that since it wasn't a specific domain, I can draw and represent any number in between them. So I draw my line with a ruler nice and straight like that. And that gives me a general idea of what the graph looks like. So then this last part says, use the graph to estimate the number of miles the fish swims in 3.5 hours. So here's what I do. I'm using the idea that I can read a graph, and I scroll over here to where 3.5 hours would be, right about here. And I just trace this up to my graph, right there. And then what I do is I trace it straight over to the left, and I say, where is that touching the y-axis? Well, it looks to me like it's a little bit above where we had the other point. So I would say it's somewhere like around 1.7 or 1.8. So maybe I'll say 1.75 miles. That was me using the graph to estimate how much for 3.5 hours. I could do the same thing for 8 hours. Out here, if I wanted to know what 8 hours is, I would trace it up to the graph and then trace it over, and it looks like 8 hours would be 4 miles, using the graph to estimate a value. Okay, let's turn this over to the last page, which was on scatter plots. I think scatter plots is probably the easiest part of this whole thing, and yet for some reason scatter plots often give people a lot of trouble. So if we read through our problems here, the first thing it asks us to do is graph a scatter plot, which means graph points. I think all of you can graph points by now, so if you think about this, this is kind of like an X and a Y, and that means this is like an X and Y coordinate, 1988 and 36, like that. And we'll do this for each one. So I'm going to graph 1988, and I'm going to go to where I think 36 would be. Well, here's 30 and 40. 35 is in the middle, so slightly above, right in there. And I'll repeat that for each point that I'm going to graph on here. 1996, 32, maybe here. 2000, also 32. And then 2004, 42. So all we ever asked to do in that one is graph a scatter plot, which is about as easy as just plotting points. Maybe the hardest thing you'd ever have to do is make an X and Y axis that your numbers would fit on. If you look at this, we had to graph years on this one and percent of 24-year-olds on this side. So if you look at it, the scales represent years here, and on this side, percents. So you sometimes have to make sure your graph can fit what it is you're talking about. Okay, the next part of this says write positive, negative, or none to describe the correlation illustrated by a scatter plot. Okay, what that means is people want you to be able to look at a graph and say, can I tell what's happening to the data in general just as a quick picture? Is it going uphill? Is it downhill? Is there just no relationship whatsoever? Are the points all over the place, or what? Maybe it's a good time to talk about drawing a trend line, which is basically showing the general idea of the data. So what I like to do is I sort of highlight most of the data like this, kind of put a block around it, and then I draw my trend line right through the middle of that data block, like that. Can you see how this line is going downhill? Well, if you had to pick which one of these words means downhill, I think everybody would say negative, and that's correct. It is a negative correlation. So correlation just means what kind of relationship are you seeing in the graph? And what we see here is a negative or downhill one. See, if you look at this one, it's talking about temperature compared to the number of people taking tests. Hopefully you read that and think, how does temperature have anything to do with someone taking tests? But who knows? Whatever, let's take a look at the points. The points, like, there's no general upward trend. Like, if we look at this part, it kind of looks up, but what about all these points over here and here? Same thing true this way. If you look downward, it kind of looks like these go down, but what about all these ones over here? In other words, they're scattered all over the place. In this case, you could say that there really is no correlation. There's no relationship. And if you think about it, what kind of relationship would there really be? Because the temperature goes up, more people take tests? Or because the temperature goes up, less people take tests? What do they have to do with each other? The answer is, there is no relationship. None. Okay, so then let's look at number 4. Sometimes you have to do this in word problem form too, but if you think about it, I think you can usually figure it out. It says, identify the correlation you would expect to see between the number of pets a person has and compare that to the number of times they would go to a pet store. Well, this is kind of dumb because there's all sorts of variations in that. You know, maybe you have really good dogs that don't need you to go to the pet store very often. Or maybe you have lots of dogs that don't eat very much. Or maybe you have lots of dogs that eat a lot. Or a few dogs that eat a lot. Who knows? But I think the idea is what would you expect to happen? If somebody has lots of pets, do you understand that the more pets they have, it's probably going to mean that they're going to go to the pet store more often to get things, to buy supplies, who knows what they might need to buy. But the idea is that if you have a lot of pets, you probably make a lot of trips to the pet store. And what we would say is, as the number of pets goes up, the number of times they go to the pet store also goes up. So as the number of pets goes up, the number of times to the store goes up also. So one thing positively affects the other. One thing going up causes a positive change in this one. That is a positive correlation. See, in number 2, this is a negative correlation because as the time goes up, the number of people painting the house goes down. So the time negatively affects the number of people for the house. Okay, last part. It says, Neil kept track of the number of minutes it took him to assemble sandwiches at his restaurant. The information is in the table below. And again, they want you, number 5, to graph a scatter plot. X's and Y's. So I'm going to graph 1, 3, 2, 4, 4, 5, 6, 6, and 7, 7. Done. Draw a trend line. This is what we were talking about earlier. What's the general trend? If you look at it like this, right, all the points fall in this small area right here. So if we draw a trend line, it means to kind of highlight the area and then draw a line that goes in the middle of that area somehow. Kind of like that. That might even be a little bit high, but it's the example that matters right now. Draw a trend line, done. What kind of correlation do we see? Uphill, right? So positive. Maybe you could say as the number of sandwiches goes up, the time it takes to make them goes up. That makes a lot of sense, right? Okay, based on the trend line you drew, predict the amount of time it will take Neil to assemble 12 sandwiches. We just did this on the other page, right? Let's go over to 12 sandwiches and trace it up to where our graph is. I got it right here, and then I traced it back over to the y-axis, and it looks like I'm just short of 11 minutes. So because you might have drawn your trend line a little bit differently, you might have a slightly different answer. But it shouldn't be too much different because these numbers, these dots are very close together. So when you draw your line through there, you might have something slightly different, but not much. I would say that an answer for this for 12 sandwiches should probably be between about 10 to 11 minutes.